OK, now let's do a walkthrough using the same code as before, but now I'm going to use %n to cause some writing to happen in addition to reading. So just like before, we have some buff of size 64, and we're letting the attacker write into it, and then we're calling printf with buff as that all-important 0th argument, the one where we look for percent formatters and match them up with arguments on the stack. But this time, instead of writing %d, %s, we're going to write %d, %n and see what happens. So what does printf do? As always, printf goes to the 0th argument, and it starts reading the characters one by one. And immediately it sees, oh, %d. That means I need to take the next argument on the stack, treat it like a number, and print it out. Well, the next unused argument is arg1, 4 bytes above. And that happens to be the value 42. So just like before, we're going to read 42 and print it out. So there it is. We see %d, we go to the stack, we grab this argument, and we print out 42. Wasn't supposed to be an argument, but printf treated it like an argument anyway. OK, what comes next? Well, now we see %n. And printf starts thinking, well, it's a %n, so I have to write something into memory. I'm not going to print anything, I'm going to write something. So where do I write is the first question. What part of memory do I write my number to? And remember, %n matches up with an address on the stack. That tells you where to write. So what will printf do? It will go on the stack, look for the next unused argument. And we've already used this one, secret number. So we go to the next one, which is secret string. And that's an address. So we're going to read that like an address. We're going to go to that address. And this is the location where we're going to do some writing. So printf now knows. I'm going to go here and write some data. So PANC, it's going to be gone. We're going to overwrite it with some data. Now, what data do we write? We figured out where to write. It's down here. But what data do we write? And remember, %n writes the number of bytes printed so far. So if I check my output, how many characters have I printed? I printed a 4, and I printed a 2. That's 2 characters in total. So I'm going to go down here in memory, and that's corresponding to this argument. Follow that pointer, go down here, and I'm going to write the number 2. So it's gone. PANC is gone, and instead we have the number 2 written into memory. So that's what %n did. It took the number of bytes printed, namely 2, and it wrote it into memory based on the pointer that we provided on the stack. Go on the stack, find the next argument, treat it like a pointer, go there, write the number 2. So this particular exploit will print out the number 42 and then write the number 2 into memory. So that's what this exploit did.